Last time we met three-phase, and that magic number, the square root of 3, now let's put it to work. This is the math you'll actually use in the field, finding the power a three-phase load uses and the current it pulls. It comes down to one formula. Remember why the square root of 3 shows up? It's the bridge between line and phase values. And the beautiful part is, the formula uses line values, the ones you actually measure at the panel. Apparent power S equals root 3 times line voltage times line current. That's in VA. And for real power, the watts that actually do work, you multiply by the power factor. P equals root 3 times line voltage times line current times power factor. That's the three-phase power formula. And notice, it works for both Y and delta. You don't even need to know which one you have, as long as you use line values. There's one assumption baked in, a balanced load. That means all three phases draw the same current, which is the normal case for motors, heaters, and most three-phase equipment. So each of the three lines carries that same line current. And in a Y system with a balanced load, the neutral carries almost nothing. Let's find some power. A three-phase load on a 480 volt system pulling 20 amps at a power factor of 0.85. Apparent power first. S equals root 3 times 480 times 20. That's about 16,600 VA, or 16.6 kVA. Now for real power, multiply by the power factor. 16,600 times 0.85. That's about 14,100 watts, or 14.1 kilowatts. That's the actual work being done. Now the one you'll use most, finding the current. Say you've got a 10 kilowatt three-phase heater on 480 volts at a power factor of 1. Rearrange the formula. I equals P divided by root 3 times line voltage times power factor. That's 10,000 divided by 1.732 times 480. 10,000 over 831, about 12 amps. And that's the number you'd size your conductors and your breaker around. To recap, three-phase power is root 3 times line volts times line amps times power factor. Use line values and it works for Y or delta alike. No need to know which. Flip it around to find current, and that's how you size a feeder. Next time, transformers and how we step voltage up and down. See you at the board.